Hello, everyone, and welcome to Maker Show. My name is Sherry List, and I'm one of your hosts today. And we are back with another episode of our show, which we are going to feature an innovative project. Before I hand it over to my co-host Goran, I want to mention to you all that our show has a code of conduct, which is featured on our main meetup page. And I really want you to familiarize yourself with this code of conduct. Long story short, we just want you all to be mindful of each other and to be kind with each other. And so, Goran, how are you doing today?
Hi, Sherry. I'm great. What about you?
I'm fine. I just started to use my Nintendo Switch Ring Fit, and
Oh,
I'm pretty pumped right now. It's pretty cool.
nice. That must be fun. Yeah. So, hello, everybody, and welcome to another episode of the Maker Show. It's a monthly show, runs for 1 hour, where we feature interesting projects done by community. And hopefully, those projects can inspire some new innovations and creations. We focus on highlighting projects that are focused on IoT and AI. If you have such an interesting project, please reach out, and that is your chance to get Azure Maker Badge. And if you stay tuned until end of this show, you could get Azure Learner Badge. So, Sherry, who is our speaker today?
So, our speaker today is Sara Olsson, and she's going to give a talk about machine learning that is used for the camera traps and then running inference on edge. She will demonstrate the image classification from model training to deployment and using tools as Edge Impulse and Azure IoT Edge and OpenMV camera board. So I would just say that let's have Sarah on the stage.
Hey,
Hello, Sarah. So, how are you?
I'm good, thank you. I'm excited
Are
to be
you
here.
ready? Yeah,
Yeah,
great. We look forward to see your project and what you prepared, your story. So, not to take any longer, stage is yours, and just to remind our everybody who's watching that you can ask questions, and in the end, we will repeat those questions and ask Sarah about the project. So, stage is yours.
thank
Yes,
you.
and I'm going to share your screen right now, Sarah. Yes,
Yeah, can you see my screen?
yes, we do.
Yes.
Great. So today I will give an introduction to how camera traps are used within wildlife and target the need for embedded machine learning, especially when it comes to protecting threatened animals. So during the demo, I'll open up Edge Impulse Studio and train an image classification model, which we will then deploy to an OpenMV camera board and test it. And also I will connect the board as an IoT device on Azure IoT Hub. And we can then send the classification results to the cloud and make use of them in like a mobile application to see what's happening. And the time we have left, I'd be happy to show some insights from an application that I've been involved in, a camera trap project. So, and just as a teaser, I will open up, oopsie doopsie, not that screen, that will be Inception. So, I have on my wall here some images, and let's just see if something is coming in here. Yeah, we can see that we have labeled zebra. We have labeled elephant. And let's see, buffalo. And this is the OpenMV cam, and I have a solar powered, this one here to charge the camera. So that's what we will be building today. And a reason that I'm here today is also because my TinyML project on Hackster. So that was a challenge from Hackster and Smart Parks and other partners, where the challenge was to imagine this this large collar on an elephant, and which was equipped with sensors and a lightweight processing unit. And it was encouraged to build TinyML models with edge impulse and then kind of create a solution from it and do a proof of concept. So what I did was that I created a model to track the activity of the elephant, analyzing whether the animal was still walking or rushing. And that was trained on accelerometer data and meant to be deployed on this small device. However, what I find most interesting is to create a combination with the camera trap. So that's kind of where I put most of my efforts. I imagine the collar to be a great way to trigger that the animal was close by and then start the camera. Then I focused mostly on the model here. And similar to what I will use today is that I use the OpenMV camera and edge impulse for model training. We also got an account on the Azure IoT Connect platform. But that was a trial which is ended now, and I use Azure IoT Hub by Microsoft on a more daily basis, so it felt natural for me to just proceed with Azure. Anyway, this is what it looked like on AvNet. I had a map and kind of tiles for the telemetry data that came in from the device. And yeah, for those interested, this article will be linked afterwards. And now let's have a look at some different camera traps and how you may use them for different purposes. So a common setup for camera traps is that they capture images on or when a motion sensor detects activity in front of the camera and then saves the images to maybe an SD card or also sending the images to a server. However, the analysis, whether what we see in the image is performed after reaching its endpoint. Whereas with the embedded machine learning, we do this analysis on the actual device, and it's possible to process the data before we send the information to before it's uploaded. So, and many times it doesn't even have to be the image. Maybe you just want to send a thumbnail to be sure that it is a correct event. But if you have a model that is very accurate, maybe you can just send information that, oh, we have an elephant here. So this is kind of where I will be focused on today. And also looking at different environments, I would say that this kind of edge intelligence has some benefits in some scenarios that may happen in a place like the savannah. For example, when it's likely that other animals will be present often, there will be many events sent to server that are not interesting if we just capture everything that moves in comparison to like this scene. You maybe see one animal or two animals passing by, where at a water hole, you'll see animals all the time. And at the same time, that's where you're maybe sure that animals will be present. And also, if the camera is placed far away, like in this scenario, and many motion sensors are effective in a range about 10-30 meters, then we would need another way to pick the events, and we could benefit from image processing at the edge. Just want to make sure that you can hear me.
We
All
do.
good.
No worries.
Can you hear me when I'm talking?
Yes, definitely, we do.
Yeah, sure. I just want to make sure because I can't see if you're writing messages to me, I can't see them right now. Okay, that's great.
We will ask questions afterwards, so no
Yeah,
worries
yeah.
about that. Yeah.
Great. However, if the case is that the camera is placed far away, it would be great if we had another way to pick the events, and then we could benefit from image processing at the edge, and without having to send everything to the cloud. So we should ask ourselves, when do we need the information? Are there images for like a research project where analysis will be conducted weeks after the period of data? Maybe machine learning could be a useful tool to sort and count by species, but then you would probably not care about inference time or computational power, and rather just do a batch classification in the cloud. However, when the purpose of the camera is to protect animals, it's vital to provide these insights in real time, and letting the rangers being able to act before something happens. And also, what quality of images do we need? I've seen the BBC filming of the Siberian tigers for the Our Planet series, which took them like months to collect. And of course, when you get a sight of the animal, you wanna have good quality. However, if you just wanna know, is it a tiger in this location or not, low quality could be okay. And what level of automation do we need? And here's where IoT comes in. I mean, it's different if you have a camera trap at your summer house, or if you're protecting a whole national park and you really need to be able to set up automation around that. And here's where I have the focus today again. And just a note, you can of course like combine, look at your needs and create different combination. Maybe make use of edge intelligence and on a larger device and save quality images on a memory card. But yeah, this is where we are today. And let's train this TinyML model. A quick overview of the process. We have the data set, which we will upload to Edge Impulse, train and export the model in the TensorFlow Lite format to the OpenMV camera, and then we'll send events to Microsoft Azure, the IoT Hub. And that's what you saw in the beginning, the teaser demo. That's what's happening there. So let's go to Edge Impulse. So this is okay. Let's just create a project. And yeah, so this is Edge Impulse. It's a tool for training machine learning models that are optimized for speed and efficiency. So it's perfect to use when building solutions for edge intelligence. And we have three main steps, which are data acquisition to collect your images, and designing and training your model, and then exporting. But you also have a set of really nice features like the device functionality. You can connect devices to both collect data and also to later test the model. And here we can collect some data by connecting boards or using mobile phone. What I often do is, if I already have a data set on my computer, is that I upload them like this. And yeah, I also can show that this data set that I'm using. So So the thing is that this dataset was meant to be for object detection, meaning that it might be several animals in the same image, and maybe like, hey, here we have an elephant in the same image as the zebra. So that wouldn't do very good if you just said that all of these are zebras. So what I did was I created a Python script to crop the images so it's just the animal centered. So let's say we want to use all of these, and we split 80% for training and 20 for testing, and say like this is zebra. And because some of these steps takes a while, I do have this already prepared project here where I have over 1,000 images and 4 labels, and we can see that there are about equal number of images. If we also want to add the elephants, we use the crop one here as well. And we upload them. I don't think I will upload all the 4 classes now. Let's go to the impulse design, which is really the training pipeline. And with these blocks, we define how to treat the raw data and what training block we'd like to use. And we can see then the output format. And here, Edge Impulse will recommend, if I have my image data here, and if I add a processing block, the image will be recommended based on the type of the input data. And also for the training, transfer learning is really a key concept here. We can have a quite small data set and make use of this pre-trained model. And we see that the output features will be either elephant or zebra. And then we save this impulse. And now we can see also details about this, the input, which are, we can pick the grayscale for now. And then our features are really all pixels of the resized final image here. And we can see that the on-device performance for preparing the input, very quick. And then we need to generate features for the data set, which might take a couple of minutes. And that's why I did this before for the one I have 4 classes. And the feature explorer here is a really good way to see if the quality of the data set. And in the best case, we would have real clusters that are really separate from each other, but animals share many features, and they do come kind of close to each other. But I would say we have kind of red over here and blue a little more here, green, yeah. It's not the perfect, but will do. And yeah, this is done as well. Then we can go to transfer learning, which is the training step. And good things to know is, so you have the interface here, but if you do want to switch over to the expert mode and see the code behind, you could do, and you can change this. And let's go back here. And what you also might want to do sometimes, if you need an even smaller model, is to downgrade to this one. It's around 200 kilobytes in size, while this one is about almost 700. It's still very small, but sometimes you need a really small one if you're running on your microcontrollers. So let's start training for this one. And well, it doesn't take too long, but we can again go over to this one, which is done, and look at what result we have. We can see the confusion matrix. This one is pretty good. We can see, for example, that sometimes we have a rhinoceros, but it's predicted as buffalo, 20% of the training, the test images. So we can expect for some faulty predictions later. And here we have the option to connect the device and do live classification, like on my phone. And we can put version of the training and go back. It's a pretty new feature, so it's great to have. And you can also, it's good to know you can share these projects. But for now, let's go to deployment and build here. So if we are doing a project with audio, image, or accelerometer data, there will be options to download pre-built binaries, and you always get the option to download the libraries and then integrate the model with a solution by yourself. And you can also use the WebAssembly if you want to use it in a mobile or web project. But for now, I press the OpenMV and download. And you always get this advice how to use this. If we open up this one, which I already have here, what we get here is label file with our classes. We get the TensorFlow Lite model file and a sample classification script, which we can open up in the OpenMV IDE. And what it does, it takes this model file and labels, and for each tick of the clock, we take an image and we send it to the classification model, and we will just output the result for now. So if I run this one, we can see in the terminal, I'm not sure if it's too small for you, but what we see now is that elephant is close to 1. Here we got the zebra very close to 1. Buffalo, sometimes close to 1. And so what I did for the demo was that I also connected, I extended this script to also make use of MQTT and send this to IoT Hub. And what we need to do then is to just look at the IoT Hub here. So I have just created an IoT device here. I click New and just enter the name. And I can retrieve the connection string. I copy that and I put it here to parse to get everything that I need to connect to the MQTT broker. And then I also needed to get this SAS token. And that's something you could do, for example, if you, I often use the Azure IoT Hub extension in code. If it shows you the code, then I could right click and say that I want to generate a SAS token and for how many hours that will be valid. So So on this device that I got here, if you see my camera, this script is what's running. So we parse the connection string and we connect to the MQTT client with the device ID, the SAS token is needed, and thereafter we, kind of similar to the previous script, at each click time tick, we take an image, we score, and in this case, if the score is larger than 90%, we will put this in a kind of combined JSON message label, score, and if I do want to send the image to show like I did in this web application, I also decoded to base64 to send this data with the MQTT message. And then to actually get the data to my web client, what I did then is, I created a message route for the for device messages. That will be the message from the classification, and I also just put a tag in my device twin. That's something we can see if you look at the device twin here. We can see that I put event listen true, and that will filter that this is a device that we want to listen on. You can just put true to, if you want to route all your messages, you can have true everywhere. And I have an endpoint to a service bus queue, which is here. So if I close this one, so now I have no client listening on this one. Maybe we can see that images are coming in. Okay, let's continue. I think we're done with this script here. And yeah, also a good advice to get started with this MQTT from a device, because often you use the SDKs for the IoT, Azure IoT devices. But what I used for this one was that this IoT MQTT sample from Azure Samples GitHub. And this was an example to use MicroPython on ESP32, but I used it to use MicroPython on the OpenMV. It's a lot the same. So what I combined was actually the script that I downloaded from Edge Impulse together with this script to upload the data. Yeah, and also the web client I was using is, let me open up here. Yeah, there we go. Sorry, it's on my other screen. So this web client is a React application which makes use of this Azure package service bus. And when I get I subscribe to this queue that was the endpoint on the IoT hub, then I will set the latest message to what came in, and that is what I show in the front end. And yeah, that's, I think now we have the full cycle of the demo. So let's, as we have some more time, okay, we have some steps. Here's a close-up of the OpenMV camera, and we have done all of this stuff. Whoops! And yeah, so I'd be happy to show some real usage of camera traps. At university, when it was time for the master thesis, I was very eager to find a way to apply computer science with animal conservation. So along with my friend Amanda, who also had knowledge and interest about cameras and image processing, we got in contact with a research project for a project where sensors were used to protect rhinoceros from poaching. And so this is the kind of title for our from our paper. So for those interested, we have about 40+ pages about machine learning for animal detection, classification, and tracking. So in that paper, we are more focused about like model architecture and algorithms about tracking the animal as well in video content. And we tried a different set of different hardware setups. So for example, this one was the first one. We had a controllable IP camera. We could pan, tilt, and zoom at the zoo we have close by, and we had this Raspberry Pi in a solar-powered cabinet here, which was running the ML model. And then when we found some events, we sent them to server, and similar to my demo here, we had a web client that could display the events that was happening. And so this is not really TinyML, but it's still embedded machine learning. So or machine learning at the edge. We're doing the inference before we send everything to the cloud. But these models were several megabytes in comparison to those from on this one, which are about 700 kilobytes. So that's a difference. And also these are for model, for object detection. And yeah, sure, couldn't you, oh wait, just want to mention that after this setup, we tried to have instead various microcontrollers like this one here, ESP32, to capture images and send to this Raspberry Pi instead of having the large IP camera. Of course, it's nice to have that quality, but we imagine, okay, so if we're going to Africa and put this in the savannah, can we bring the big IP camera? Maybe, but that's a whole project to get that running on the solar powered and everything. So we were trying to see how small can we go and still have results. And Sherry, can you please play the video from this?
Sure, I'm going to do that.
Yeah, fun that the audio is still there. I forgot that. Anyway, what you saw was the small device was capturing images and sent to in this case my laptop, but really the same program was running on the Raspberry Pi. But for debugging, we also used WebSockets to display the what was happening out there. And also, when speaking of this project and applying things in real, I want to mention this OpenSet recognition problem. And well, if anyone has like the solution for this, please reach out to me, because this is always hard when doing a classification model. You're training the model to distinguish between a set of classes, and as soon as there are any other animals that you haven't trained on, there will probably often be a faulty classification of, for example, when we tried a model without the classes buffalo or elephant, these large animals were all classified as rhinoceros. And when we added them, we have that buffalo and elephant are all correct. And so it's a hard decision on where to put kind of the limit on how many classes to include. Would be very I would be very happy to just having to like include the classes that I'm interested in. So that's one of the problems you would encounter if you're trying to do this in real. And there are research about this to like make use of different loss function to cluster the classes so much that you can see that you have an unknown class. And yeah, let's see if I have more slides. Yeah, so this is just a question: what can we put in the wild? The trade-off between how small, as I showed you this, we have this ESP32 can run TinyML. We have the HiMax over here. You see it's very small, or we can go bigger with Raspberry Pi and you make use of IoT Edge, for example, and train those kind of classification or even object detection models. And yeah, speaking of that, I think I have time to show if I want to make a detection model of this, to actually also have the to be able to find several animals in the same image. You can make use of the object detection. I don't think on the microcontrollers and TinyML that many devices are capable of doing this. I know there are lots of work being done on that currently, and I'm very eager to also being able to run object detection on these small devices that I've shown. But so what I did in this case was that I uploaded all the same data set. I had to convert it from, as we can see here, the data set was only a number of the class and the bounding box. So I used this one from Microsoft. I have an open source on annotation converter, so I could convert from the YOLO format to open or to this custom vision format, and then I uploaded every image to here, and then you can train your model here, which I already done. So just to show kind of another way to apply machine learning on the edge. And from here I exported, and then I can choose a Docker file, which has support for Azure IoT Edge. And I may choose a Raspberry Pi and download. So what you get here is you get this there, IoT Edge. It might be the case that this view is very small for you, but what you get here, you get a Docker file that sets up the environment on your edge device, like what Python packages you need, and you have an application that sets up a web server waiting for someone to call the web server and with an image and ask for classification. And same here, we have the labels and we have the model. And note that this model is about 11 megabytes, which is much larger than the 700 kilobytes we had before. And this one, let's see, yeah, I have it running here. So what I did was that I put this model folder that I downloaded from Custom Vision to be a module. And I have here the script. It's waiting for example, this classification endpoint here. And if we receive a request with an image, we will classify it and return the result. So I got my postman here and I send this, and hopefully we will get a result. So what I put in the body was the image, and here we get, okay, let's see, maybe it's very small. So, but I didn't see actually the image that I uploaded, but it was one of the elephant images, and we got actually the bounding box now. So now we are able to find several animals in the same image, which is probably even more relevant for the African savanna animals. They are not very often by themselves. And so now I'm just running this on my computer, but we can from here upload it to have, this is, for example, is a Raspberry Pi that I have on my desk, but we are running out of time, and I thought this one was a way to show anyway. And we can see here the output from the module, the IoT Edge module, is also outputted here. And yeah, as this image contained 2 elephants, and we got the result here, 2 elephants. So that's great. And I think I'll just proceed to my thank you screen.
Yeah,
Awesome.
Thank you, Sara. It was a really interesting talk, and I can see that we have a lot of discussion in the chat as well. So Goran, is there any question?
Yeah,
Anything
there
you want
was
to highlight?
there was discussions, and one question that I noticed, like, Sarah, could you tell us something about Azure costs with these things? Like, is it super small to train a model, super high? What is your experience?
Oh, so actually, we have Azure at work, and every month we get this $130, I think. What's it? It's a special subscription, and so I get this from my anyway. What I wanted to say was that I never I can see that I never make use of much of those money. And I mean, it depends on how many. It depends on how many devices and how much data going around you have. If I would set up this in a whole national park, it would be more telemetry sending, and depending on if you use custom vision and train a lot of iterations and stuff, that will also increase. But for debugging and creating a project like this, that's not costful or expensive, I would say.
Yep.
And especially when you run this edge inference, it doesn't, and deploying the model on the devices, it doesn't. You can run your model for free if you're running it on your devices.
Yeah, great. I haven't noticed any other questions. I don't know, will some pop up soon? But
I wanted actually to mention one thing here. Let me see if I can find it, because we have since I work at Microsoft, so I know a little bit about the costs as well. So there is a calculator that we have that you can use that one to actually to calculate your consumption. I'm trying to find the link. I will post it in the chat as well later on. So
awesome.
I can see actually here that there are a lot of messages for you as well about your talk. So everybody's happy about it. So that's very good. And we had a very good engagement in the chat. That was impressive to you all. So
Yeah.
so should we? Let me share my screen. Oh, there is one more
One question coming up. So, what was the hardware and the model sweet spot you found in getting a good performance for your inference model? That is Mark asking.
Yeah, that's a hard one. I mean, if I'm using object detection, I'd go for like a Raspberry Pi or more similar device like that that can run Docker and like have those capabilities. But I like this OpenMV camera. You can have a pretty good, especially with. So I actually have two of them here. One is Plus and one is the standard one, and I get the better models with the Plus one.
Great. And what's the next big thing you are building?
Ooh. I'm always eager to have this in production, and but it's hard to go to Africa currently.
No.
But yeah, at work I do stuff with public transport, and yeah, so a lot of devices and machine learning towards public transport.
Nice. Awesome.
That's a good
Okay,
one.
we don't have any more questions, so I think we can start wrapping up.
We can count till 3. So
Yeah.
3, 1, 2, 3. No question. The time is over. So then let me share my screen.
Thank you,
And
Sarah. Great presentation and demo and everything. It was really fun to listen to.
yes. So I'm going to highlight a few thank you to here as well. So yes. Okay, as we promised in the beginning, you can all get an Azure Heroes Learner badge by scanning this URL and follow the instruction to get it. And if you don't know about this project, this is literally a token of appreciation for Microsoft to all of you. Yes, he has a badger. I also have a badger here. So, so so this is a community project that we have at Microsoft. Is based on blockchain to be able to have a unique code for all of you. And if I want to be precise, it's based on Ethereum. And when you scan this QR code, if you never had any this badge before, any of them, you need to download a kind of a digital wallet to save these funds, and then you need to set a password there, and you should remember that password. And also, if you change your phone, you need to back up your wallet and import it there. I guess we have Goran there that to who've been through that process as well. So it's very
Yeah,
important.
there was some tricks to do.
Yeah, because you can lose the badge, actually these badges as well if you don't do that. And so if you want to know more about this project, you can go to aka.ms/azure.heroes and read about the program, and you can nominate yourself. We mentioned in the beginning that we are going to give a maker badge to Sara for creating this
Yay!
cool project. Yes, so you can. There is a form there. You can nominate yourself because we have multiple different type of categories there. Or you can also nominate one of your friends as well. If you know that somebody in the community that, or one of your colleagues that is doing a great job, you can nominate it for different badges that we have there. And we need your feedback. So we want to improve our show, and we also want to know that if you want to be maybe even our next speaker, so you can let us know there. And if you also have some feedback for Sara, we will actually share those feedback later on with her as well. And we are going to choose one of you who fill this feedback form, and you will get some surprise boxes from us as well. So yes, so let us know. We want to improve, and we want to be the show that you love to watch every month. Speaking of that, we have already announced our next show with Pete. It's going to be on March 17th. And I wanted to also mention that because there will be like a time zone differences, there please make sure that check out that you're actually joining at the right time, because there will be 1 hour difference by that day. So yes, so check that one as well, and we really hope to see you there. And I wanted to also mention one more community event which is coming on March 8th. And in celebration of International Women's Day, we have this conference called FTWConf. And that is going to be a really fun and informative event on the evening of March 8th, which featuring a lot of different women in tech. We really want to have you there, and you see that what are these women are doing in the community. So yes, put that on your calendar. And now I assume that all of you that you are here, you are interested in, at least in the to helping animals, because that was the whole kind of that the Sarah's project was also about. So we are also running this climate hackathon, which is a 1 week of hackathon. On March 22nd, it will start. And what is special about this hackathon is that we are bringing real life scenarios from the nonprofit organizations that are already tackling these climate issues. So if you join there, you are going to actually helping these challenges that these NGOs they're bringing up. So it's going to have a lot of impact. And imagine if even one of the you can solve one of these issues, how much of impact you're going to have for entire world. So we really hope to join to see you all there. And I know Gobran will be there as well. So
Yeah, for sure. It will be a lot of fun.
Yeah, yes, and also in order to help you to sharpen your skills, to join this hackathon, we're also running some cloud skills challenges. That it's a 6 weeks in a span. So actually 3 challenges in a span of 6 weeks. One of them is already finished. Right now we have the one about Power Platform, and then next one is going to be about machine learning. Since we have a little bit of a time, I can actually show a short video about that.
Have you heard about the Climate Hackathon on March 22nd? It's a hackathon about you, me, us and the Earth, where we'll take on the challenge to hack the climate for a more sustainable future. To get you ready for the hackathon and to sharpen your skills, we have a set of 3 Cloud Skills challenges that span the 6 weeks before the event. This second Cloud Skills challenge is all about the Microsoft Power Platform and the ways that it can help you solve those environmental challenges on March 22nd. To find out more, go to microsoft.com/AI Cloud Skill Challenge.
Yes, so we really hope to see you all there at the hackathon. Goran, do you have anything else to add? Because I was non-stop talking for I don't know how many
But you
minutes.
covered everything. Yeah, it was really, really great episode, and maybe we should do it more often. But for now, it runs once per month. Next month we will have Pete, and it will be a great talk for sure. So please do sign up on our meetup page. Click attend over there so we know you are joining, and that way you also give visibility to event. And don't be shy. Feel free to share, and invite your friends to join the show. Thank you all for watching, and thank you, Sara, for once again for great session.
Thank you.
Yes. So we can just say that see you all on 17th. Bye-bye.
Bye-bye.
See ya. Bye.